This.
All right. So can you all see my awards ceremony on Friday screen?
Yep.
All right. Okay, so just to let you know about the prizes, we have two options. Here is the one that's kind of fun is the Ping Ultrasonic. So what I did is I put the link in the slide. This is slide number 163. I just appended these announcements to the end of the slideshow. And so on slide 163, if you, or really any slide, if you see these tiles, they should be linked to the tutorial. If not, you can also check in the speaker notes, because if the link isn't live on the little tiles, you can check in the speaker notes. It should be in one of those two places. I'm trying to get them all consistent, but it's going to need a couple more passes, I think, before it's really completely no-brainer, click and go.
Andy, to make it easier on you, I'm going to withdraw my name from the contest because I both have the CyberBit Rover and I also have the Qti Line Follower. We won a prize with it.
Well, if you would kindly post any application you've got that you think is cool, we'll take that into consideration, okay?
No. Yeah, I'm going to withdraw my name from the contest because you've given me so much great stuff that.
Aw.
Yeah.
All right,
yeah.
then. So,
I love you
So
guys.
puppy's
folks, that means oh well, okay. So let's talk about that. So I sent you all slideshow links, and so here's the coworker slideshow. And could we get everybody muted there? Oh well, looks like that took care of itself.
Especially Mark.
All right, so in the coworkers, I added Hazel just to give you guys an idea of, populating one of the slides. And then Mark added Amazing Grace as baby pug. And then John LaFave added Penny, who looks like a very attentive and helpful assistant. Because I've got to tell you, my assistant is anything but helpful. All right, so right now the wins are still empty, but we've got a bunch of empty slides for you to paste in your stuff. And then likewise for the fails, we don't have any fails yet. I don't think any of you can compete with me on the slideshow stuff from last time, but.
Well, I haven't had a chance to put in my epic make your servos stay perfectly.
I really like that one. The one that we wanted that I wanted to show last time is another one we really like, because basically putting the these are things that students are going to do, and that's one of our filters for fails, is we want to spotlight things that that we do and we can expect our students to do too. So definitely put that one in. You'll be.
I will. I just didn't know where you wanted it yet, and I saw last night that you had put that in, so I was like, okay, I got to get that done.
All right.
And I'm doing some more epic fails, putting in your lock nuts backwards and having to take them off. I'm good for that crap.
Yeah. Well, me too. So so anyway, the link takes you to the tutorial where you can see the what this particular add-on does. And it basically has a little ultrasonic distance sensor on it, and the application has it scan. And it's really good at escaping corners. How was that for visibility? Could you guys see that okay? Thumbs up, maybe?
Yeah.
All right. Okay. So that's one of the prizes, and then the other one is the Qti Line Follower, which, oh shucks, we just have a picture here. Yeah, I have one on the desk. Don't know if I can grab the course, but I might try that later on. So each of these has their own tutorial to go with it that shows you, basically how to put it all together, and then how to get the test code going, and then how to make the application go. There's lots of testing with the QTIs. All right, so So I highly encourage you to post your wins, fails, and coworkers, because I'll tell you what, right now, if one person posts and wins, they get the win, and likewise with the fails. So let's see some more competition there. Next announcement, Parallax is able to drop ship to your students. So if you are doing remote classrooms and distance learning with your students this fall, what you can do is you can coordinate with sales@parallax.com to find out how to set up the drop shipment to your students if you need each of them to receive a Cyberbot directly. Some of you I know, or I have heard, have pretty good distribution systems at your school where basically you still do the normal school orders as usual, and then the cars go by in a procession and each picks up their packet. So whichever is your preferred way of doing things, we can support it. You know, we've been doing purchase orders to classrooms for quite a long time, but now we have the drop shipment option for you if you need it this fall. Here's a quick little video on cleaning up your, or basically sanitizing your robot for the next student. And by the way, these are all on the slideshow, so you can get to them. And the main thing about the CDC website is they're saying for alcohol, electronics, or I'm sorry, for electronics, alcohol is the way to go. And make sure to unplug power. And a spritzer works really well, and then you can just hand dry it off. Now I want to point out one thing here. Let's go back to the ingredients. Okay, so so notice this is 70% isopropyl alcohol. Sometimes you can also find little spritzers at the store, like this one shown here. Now this one, when you look at the back, let's see here. All right, so when we look at the back of this one, let's see if we can bring it into focus. See the active ingredient, ethyl alcohol, 75%? That's okay. Now, some of them, either ethyl or isopropyl alcohol, if that's the only ingredient, it's okay. But if you get something like lemon scented, that's no good. We want, because basically alcohol is used to clean electronics, and so when you're soldering, basically the thing we use to clean off the flux is alcohol. And so if you take pure alcohol and mix it with either ethyl or isopropyl is fine. If you mix it with purified water, like distilled water, you're good. But if you have, like at the store, I've seen little spritzers that also have a little bit of hydrogen peroxide in it. That's going to corrode the electrical connections and cause the device to fail after a certain number of years. And then likewise with some of the scenting stuff, it's no good. So just as long as you find something that is pure isopropyl, or I'm sorry, that has only isopropyl alcohol 70% or above as its active ingredient, or ethyl alcohol is okay too, though there are temptations involved with that for some, so we want to avoid that. Those two are safe for your electronics. All right, so next up is slide number 75. All right, so did you guys see this in the email? Okay, very good. It's a lot of our teachers, or some of our teachers, have to take the robot with a nice demo to show their purchaser so they can get a feel for what they're getting. And they're also popular. It's, once we get back to the old normal, when there are choose your optional class days, teachers bring out their demos. And when you've got it center mounted, it looks cooler. center mounted has some pluses. The pluses for center mounting with the output shafts towards the middle of the robot, that was the original design intent. It's more like the Roomba, and the maneuvering is good. It can rotate in place. Now, the drawback is that if you need to recenter the servos, you need to bring the screwdriver in from behind, and that becomes somewhat of a challenge because basically what you're trying to do is get the screwdriver in past the batteries here. And so it doesn't really work unless you have a little eyeglass screwdriver. Now, we've managed to get beyond that by the main reason we centered it in the first place is because, or the main reason that we sometimes, I'm going to get back to that. Those are the minuses. Now, for front mounting, yeah, centering adjustment, basically, if you want to center your servos when you have them front mounted, you're basically putting the screwdriver in right there. So it's very easy to get to. Other advantages are when you have something like the gripper or the ping that that we showed that's up for grabs for the contest. By the way, Ken Gracie made this. He has a snow fairing version of the Cyberbot, and so this actually does quite well in the snow. He just used hot glue and some 440 screws. I think they're 1-inch long 440 screws, and just put them all around the tires, and it works great on the snow. But whenever we hang devices like this, you want to have those wheels front mounted. You want to take this, if they're center mounted, you want to take them out and put them back in so that the drive shaft is forward as far as it can be on the robot. That way, this extra weight on front won't tip it over. Okay. Now, also, when the robot stops, it won't do a little backwards wheelie. The drawbacks of front mounted is that maneuvering can be clunkier, and also another issue is that when the robot tries to turn in place like this, there are some surfaces where this tail wheel dragging along, when you have the wheels further forward, it's a longer lever that it has to drag that tail wheel along. And so what it means is that on some surfaces, instead of having it rotate in place, the wheels will actually slip. And so it won't execute a turn as well. So that's another reason we like center mounted. Now, I'm going to show you later, one of the main and most compelling reasons for having the front mount being the adjustment, we have a way with the Cyberbot to make that not really matter. That servo adjustment is just to make the servo stay still when you tell it go speed 0. Well, you can also tell it go speed none. And regardless of whether the servo is well centered or not, it will definitely stop when you tell it none. And so that takes away some of the urgency on periodically recentering the servos to keep them still. And if we haven't already, we need to update our tutorials to use none instead of 0 whenever we're trying to keep the robot at a stop. All right. Any questions before I move on? Silence. Well, remember, feel free to jump in. This is a very easygoing and open format. Okay,
Andy,
next is,
Andy,
yes.
I have a question. This is
Okay.
Lisa. Does it matter for this class whether we're front mounted or center mounted?
No, I mean, it's nice, especially if you're doing any social media posts, to have it center mounted because it looks cool. But aside from that, I guess the other thing is if you have a linoleum floor, it's going to potentially do that, not turn as well as we want it to trick. That's the only thing to really be aware of, is that you might see it, you know, kind of slip in place instead of turn properly on some surfaces.
And then in the instructions, it had us mount it, what, centered?
In the instructions have you front mount it, and there's a little information box that says, you know, you can also center mount it.
Oh, gotcha. Okay, so if we built it just according to the instructions, then that's front mounted.
Yeah, yeah.
Okay.
And you're fine. Just keep an eye out for that slipping in place on your surface.
Okay. For us to change then or something?
Yeah, it takes about 5 minutes to undo the screws and then
Okay.
pull them out and then put them back in on the center. We have a nice little wrench in the kit for that.
Yep. And then my last question is why did they give us plastic screws if they don't tell you to use them for anything?
Well, they should have. That's a very important point, and I'm glad you asked.
Yeah, because every instruction I followed didn't say anything about using plastic screws. It did say about using the lock nuts instead of the regular nuts.
The plastic screws were used to put the battery pack in.
Battery pack to the chassis posts, yes.
Well, how come I don't remember seeing that? Because I put the metal.
Okay, so here we are.
Okay.
Nylon flathead. Okay, so by plastic, it did not specifically call out plastic, it called out nylon.
Nylon, and I just kind of overdid that, so I got to take the 2 metal ones and put in the 2 little nylon ones.
Yeah, and I want to emphasize, can you please do that after we're done with this
Yes.
session today? It's very important. The metal
Yes.
ones can actually, the cover on the battery is just a thin little sleeve of plastic. And if your metal screws can actually nick it, go through and short to your chassis, and your battery pack will get so hot it'll melt part of itself.
That's lovely. Okay.
Yeah, so these
There's
are
my
very
second epic fail.
you can do 2 slides and then you're doubling your odds.
Yeah. Hey, I'm going to be one of the ones that probably has all the epic fails because I don't know. I went, okay, I got the right size.
Well, so far I'm your only competition, and
Yep.
I don't know that I'm allowed to win any of those prizes. So
Yeah. Well, see, that's kind of nice for me.
yeah. Okay. Any more questions?
I went out and changed the plastic screws thinking I was going to be smart, got some flathead metal ones because I wanted it to be there sturdy.
Yeah.
But then the standoffs, or whatever you call those things it's threading into, one of mine was not cut right. And so I actually needed the plastic screws to be able to get a grip on bad threads.
Oh
So
boy.
it worked out well.
Okay. Well, do be careful with your battery pack. Like I said, if one of the metal screws nicks the battery sleeve, because basically this surface is just an ultra thin sheet of plastic, and then underneath it is, depending on which battery, it's either the negative or positive terminal. And then this chassis right here is connected through the board to the negative most terminal of the battery, which is right here. So these are all the batteries they're connected end to end in series. And so basically right here is the negative terminal of the entire pack. And so when you're over here, you're at 3 volts. And if you nick this and therefore connect it through a metal screw to the chassis is connected to this most negative battery. And so what you get is a short circuit where current travels through. And then basically the thing that heats up the most are these little springs right here. And the battery pack can melt on you. So if we need to send you some replacements, please just drop me an email and we'll send you anything you need to get nylon screws back into the battery packs.
Well, I guess thinking of doing this with the class, maybe I get a few extra kits just for spare parts, but I'm sure there's things that aren't big that I maybe just want a bag full of screws, a bag full of some of the small hardware. Can you get that separately?
Yes, you can. So at parallax.com, think if I do small robot, yeah. So like here's the electronics pack. So you can get a few of those. And here's the hardware refresher pack.
Perfect. Thank you.
Yeah, I highly recommend that. Let me make sure to.
Especially for people like me.
Yeah. So.
I kept dropping them.
Oh yeah, dropping them under things, having to go pick them up. And this little screwdriver, by the way, is not very good for the nylon screws. It's
Yeah,
not
and
big enough.
with the nylon screws also, just use a very light touch.
Yeah.
You know, if the nylon screw is still sticking up by a thumbnail's thickness, that's safe. You just, as long as the battery pack isn't flopping around, that's all we want.
Okay.
All right. Man, I'm glad you guys brought this up.
It's because it's what
Okay.
our kids are going to do. That's why. It's
Yep.
what our kids are going to do. So I'm making sure I make all the mistakes the kids do.
Yeah,
There you
and that's
go.
actually the mistakes that we make in the office. We try to also incorporate into the, you know, I'm not exactly sure why I ended up at the end of the educational resources. So next thing to talk about is educational resources. Chuck, I'm over my plus or minus 10 on having you step in, that's for sure. It looks like it's going to be plus or minus 20.
No worries. No worries. I can be quick. You ready for me?
Well, not. Okay, yeah.
No.
Let's have you take over and do your NYSERC presentation, and then I'll talk about the Parallax curriculum after that.
Okay. Just real quick, we want to just share a little bit about what NYSERC's, what cyber.org is doing with in the curriculum space. So back on June 25th, at the end of our summer conference workshop, we unveiled our new brand and our new logo. So what you knew as NYSERC, which is, again, we still have the gear for it, is now cyber.org. So we're thrilled to be able to bring you some of these new resources and the new website. So we want this website to be a one-stop shop for everybody. You can get to all the curriculum from here. You can register for new accounts here. You can see all of our upcoming events from here. So bookmark cyber.org, and any other time we reference Canvas. If you know Canvas, right, we can say Canvas and you understand it. But if you've never used Canvas before, our reference to this product called Canvas is meaningless, because nowhere on the page that we call Canvas doesn't say Canvas. So I've said enough references to Canvas. We're going to call that our curricula library. And I can
Chuck,
get there through.
If pardon me for a second. If we already had belonged to NYSERC before you changed the name,
Yep,
is it
it's all
going to be
good.
the same login?
Yep.
Okay.
So you just need to direct your instructor link to Cyber, and I'll show you that in just one second.
Okay. Thank you.
So the page is now your one-stop shop. I can find when upcoming events are coming. It links to our Eventbrite page. We've got we're constantly populating with well, we got to remove some old links there, but some new. Here's a current one. The rest of these are older. We got to update them. But let's let's move past that to the curriculum that we host. So what's cool about this new site is now we have curriculum information. That's not an account is not required to access. So if I want to learn more about Science Plus or STEM EDA or computational thinking, I can come to the cyber.org website and I can look at information about all of these courses. You're using microbits and cyberbots, and we have some microbit content in our course called Cyber Fundamentals. So I can come over here and I can learn a little bit about microbit programming with make code, which we refer to as block program. You're using Python, so we've got some Python activities. And with this cyber.org new website, I can actually see the lessons and activities that have been created there. Now, I can't access the content. That's all still protected by a password, but I can learn a little bit about what each of these lessons does. If I want to access the content, I'm going to log in, and that's going to take me to the new cyber.instructure.com. So this is what we call Canvas, is hosted by a group called Instructure. So your old link went to nyserc.instructure.com. I just need to make sure that you update and bookmark the new one. And if you don't want to bookmark it, just go to cyber.org and hit login. So once you're there, same content, just a new look. So again, everything's been refreshed. We've got new colorful graphical logos, and even our content has new images and a feel to it. So when we go to one of our newest courses called cybersecurity, for example, you'll see just a new feel, same content. Some of it's new, right? But some of it's just got a new feel. So we've got curriculum here, and we want to make sure that you realize that everything is still the same, just new logo and appreciation of our partners at the Department of Homeland Security. So it's all there for you.
Say, Chuck, before you exit that, can you show us, for example, CyberLit?
Yep. So all of this content is free for all teachers across the country. So if you don't have access yet, get to cyber.org and hit sign up. If you do have access, make sure your friends are aware, your colleagues and team teachers are aware that this content's free for all teachers. In this course that Andy referenced called Cyber Literacy, this is our introduction to cyber engineering. And what we're doing is we've got curriculum designed for 8th, 9th, 10th grade students. That's going to take them through exploration of robotics on on 3 of the Parallax platforms, including the old school Bobot, one of my favorites, the ShieldBot with Arduino, and the one you're working with now, the CyberBot. And we've got some robotics curriculum that supports learning with the CyberBot, including much of the stuff that you're learning these 3 days this week. There's the Hello World program. We're doing some work with LEDs, and there's your servos, assembling the bot. So we're doing all of this in a classroom setting for students. And this whole course, including the liberal arts content and the electricity content, is designed to take a full year's worth of instruction. And if you have any questions about this stuff, feel free to reach out to Josh, Matt, or me at any time. Andy, did that cover what you were looking for?
It sure did. Thank you.
And just last thing on the way out, there's just, again, the same sign-up form, which you need to make sure you're aware of the curriculum that you're getting has been provided by government dollars through the Department of Homeland Security, and we're appreciative of their work, and we just need to make sure that you're using it with the intent that the grant provided. So we appreciate the work that you guys are doing in the classroom and the unsure environment that you're about to step into. We want to make sure you got everything you need to be successful in the classroom. So please reach out and let us know if you have any concerns or thoughts about implementation. Mark?
I have 2 students in Russia. Is that going to be a problem?
Not for you, as long as you don't move there.
Okay.
Yeah, so our students don't get access to this content because it does include things like semester exams and study guides and all sorts of teacher resources.
Oh, I know. I mean the student content.
Yeah, but so if you're sharing, if you're a teacher in the United States and you happen to have a student that's okay by us.
Yeah, I mean, exchange students, for example, are inevitable too. So
right, yeah, that's where most of mine are from, is Russia and China. So I have.
I'll be darned.
Our favorite people. No, I'm just kidding.
Thank you.
Do you include Canada?
No. So no, unfortunately, it's domestic only. We do include the U.S. territories of Puerto Rico, Virgin Islands, Guam, and we do have teachers there who are using our curriculum. But no, I've asked, and Canada's off the table.
Thank you.
Our friends to the north. Reminder for today, if you haven't yet, try and rename yourself so we can see where you're coming from. We got a lot of representation from Massachusetts today because I can see all of your MA abbreviations in front of your name. I know we got Virginia folks in the crowd, California folks in the crowd, but you got your CA abbreviations all over the place, so you don't sort well. I know we got some Illinois folks here too, so I love to see abbreviations in front of your name. That way you sort by your state in the participants list. Give me a thumbs up if you're on board and ready to go. Give me a thumbs up in the Zoom window here. All right, look at all those thumbs. Any need for breakout rooms, let me know. Again, we've got Josh and Matt standing by to help you out with your Cyberbot woes if you have any. Andy, with that, we're inside of 60 minutes, so let's hit it.
All righty, thank you so much, Chuck. Yeah, it's during the in-person version of the workshops, I stop for a minute and have everybody sign up for that. What I'm going to do instead here, since time is short, is I'll just email a link to the cyber.org's sign up page. And so you can do that in your leisure after the session.
And you will love it. You will love it. Anyone who hasn't used it yet will absolutely love it. Andy, that's where the DNA science project comes from. And I just added a twist.
Yes. Oh, cool. So,
yes.
So yeah, I agree completely, which is why we stop in the middle of the in-person workshops and do it, and we'll have you do it as part of your homework. Now, for Parallax hosted resources, basically learn.parallax.com is where everything is. So going back to the home page here, and you'll actually see that we have a number of different robots and electronics learning platforms. So you'll be following the Cyberbot link, and or rather your students will be, and you will be, since you'll want to know what your students are making their way through. And each one of these tiles is a link to a booklet on a particular topic. And so, for example, one of the assignments we did was I sent you a direct link to navigation with the Cyberbot. And so, but here is the actual tile. And by the way, these are more or less in sequence. But another thing is that it will take you through before you start. I picked a bad example. It will actually link to previous lessons that you need to have completed. So for example, we should have right here a link to putting together your Cyberbot as something that's a prerequisite for this. I'll get with our editors on that. Does that make sense, everyone? Okay, so, and pretty much every slide is either directly out of here or has a related page that's linked in. Now, in order to get to the educator materials, just simply follow the educator's link. And then you will have access to the resources. So I just followed the Cyberbot resources link. And here we are. Now, right now, the assessment materials, the stuff with answers, you're locked out of that. But what we do have is, for example, the slides that I've been using during this. Here's the standards matrix. So for example, if you need to justify a purchase of the Cyberbots, you can go through and check off the applicable standards, and we grab the most common ones. And so you can go ahead and cite which standards the Cyberbot is set up to address in your curriculum. Okay, let's see here. Going back to the
Andy, as long as you're talking standards, the ITEEA has just come out with new standards, or there's in the process. Do you have plans to go through and align to those?
Possibly. That's above my pay grade, but I'm making a note to myself right now because we do have somebody that goes through and does all those standards alignments, and she
Yeah, new science standards are being implemented that will go into effect not next year, but the year, I think it's 21. We're finishing standard stuff, so it's going to include your engineering and technology and all that good junk too. So you might want to let those guys know it's coming.
Okay, thank you. I made a note, and we'll pass that on. And you know, given the time frame, I think we can probably, I think it's likely we'll have it updated as needed. Now logging in. All right, so I logged in on, I left the HTTP connection as a guest, and now I'm logged in as on HTTP, or when I go to the HTTPS, the secure version of it, I'm logged in as myself. And now when I go to Cyberbot resources, instead of that locked up, hey, you know, if you're an educator, you can log in and go here. Well, no, all we have is the link to the assessment material. And be careful with this because it's got, you know, questions, exercises, projects, and their solutions all in single docs. So if you end up taking one of those docs, make sure to copy and paste it to Show in folder. Here we go.
We don't automatically have access to this from going to this workshop. We need to
You
go
should have
through that process.
received an email from Parallax giving you an account name and password and asking you to follow a link. And let's see, it's the title of it is account activation, your email address, and then it says @learn.parallax.com. So I will add to your homework to find that email and make sure you're set up with your account.
If I had a account from before, then I wouldn't have gotten that email, right?
That's correct. If you already have an account, I don't think you'll have gotten an email unless the email address you used was different from the one that you have an account through.
And then we just click on tutorials, education reference, downloads, whatever it is we need once we have our account, right?
Yep.
Yep. Because I did that when you first sent out the link. So they sent me mine like right away.
Okay, perfect. Perfect. So I just went into the zip and grabbed the and lo and behold, it doesn't like pasting into my downloads. Let's oh, blast. All right, well, I might just plan to show you that next time, or let's see, I'll try one more thing. We'll just yeah, it's not cooperating. I do apologize. This computer is new to me, and so it's got some. Oh wait, here we go. It was on the other screen. Okay, it looks like on my desktop now. Navigation. See if I can extract that here. Extract. Okay, and now I have a folder. And so we have both the PDF and the Word version. And the nice thing about the Word version is that you can open it up. And if you don't have Word, you can just use Google Docs to import it. And then it's got a whole bunch of nice assignments for your students, along with an answer key for you. So there's an example of our available resources. Any questions before I move on? Okay. So the next thing we're going to do is a recap of navigation. How did the navigation homework go? Did you guys get your robots moving around? Can I get some thumbs to see thumbs up if you got your robot moving around and going left and right and forward and backward, and then clap if you ran into any trouble. Okay, I'm seeing thumbs up. How are we doing for the for anybody who's got more thumbnails? I've only got 10 visible on mine. You're muted, Chuck.
I was laughing at your jokes.
Okay. All right. Well, see. So we're going to. I'll do just a quick navigation recap. Starting on slide 40. I think I said 41. No. Oh, that's right. We'll actually start with just a program. Hello?
Well, I'm busy. What does he want?
He wants to take Andy and Alex to lunch.
I don't care. Where is he?
Go ahead, Andy, you're good to go. You're muted though. Andy, you're muted. Andy, you're muted. I hit mute all. Sorry.
Can you hear me now? Excellent, thank you. All right, so so we had you go through the programming tutorials, and so so those use some display. So what do you guys think about this while true and then things below it? Below and indented. I want to highlight this. While true is the thing that you would use to repeat statements. And when if you have something that you want to repeat inside a while true loop, you need to put it below and indented. use 4 spaces. And then if you need to sub-indent, like you might have another loop inside your while true, anything inside that loop will need to be below and further indented by another 4 spaces. The editor also substitutes 4 spaces for a tab. And so most of this you can go through at your leisure. I'm just going to go through here and point out things that I think are important. And again, I encourage you to jump in if you have any questions along the way, because otherwise these are part of the tutorial and I don't want to spend too much time on them, especially since I dwelled on the Parallax resources for too long. Another thing here is random. From microbit import, well, that gave us display, set pixel, and that gave us sleep, which is what we use to pause. But from microbit import star does not have random. Random is a different module that you actually have to import separately if you want to get some kind of random number, like in this case between 0 and 4. Remember I said that if you have a loop where you want things to repeat, you put something inside it, you've got to indent by 4 characters in order to have it be part of that repeating loop. Well, if that thing that you put inside it repeats, you also have to indent 4 more characters in order to, in this case, repeat 5 times for setting each of the 5 pixels. You see what's going on the right here? The light is traveling from 0, 1, 2, 3, etc. And again, these are part of the tutorials, so I'm kind of just doing a quick whirlwind tour and just highlighting what I think are the most important parts. And I encourage you to work through, if you haven't already done so, to hand enter the code examples. Put your web browser next to your web editor and hand type all this in, because that helps it basically become more fixed in your mind as to how things work, and ideas will occur to you. You'll make some experiments, break the program, figure out how to fix it, and those kind of things. So this is all part of communicate. And I like to talk about how microcontrollers at the most fundamental level, when you're doing an application, you're programming it to communicate, to remember, to calculate, repeat, and count. So remembering A equals 89. Well, anytime you use A after that, it'll be 89. B equals 42, and so on and so forth. So that's remember. Calculate. C equals B plus A. 89 plus 42 will be your result. Communicate. Here it's displaying it for you. This is an example of repeat and also counting. Because for x in range of 0 to 5, the in range part automatically takes you to 0, 1, 2, 3, and 4. For x in range, it starts at 0, does these things, then it advances to 1, does them again. And the tricky part is it stops before 5. So basically, the 4th time through this loop is all that happens. Then it drops out, gets back to while true, and repeats again. And like I said, these are highlights. These are part of the tutorials. However, if you want to meet and talk about any of this, I'm more than happy to set up a Zoom meeting just to kind of get us through. And what I just said about the for loop and the in range, that is, these are excerpts from the textbook. And so this is one of the, or from the tutorials on the Learn site. And so this is where we talk about that, and you hand enter the code to count to 11. The microbit has push buttons, which are really nice for doing things like starting programs. You can say, wait until the button is pressed and then get the program running. And so there are examples of using the push buttons. There are examples of checking the temperature, the light level, the level of tilt. And constants and comments, be careful with these. I know that a lot of computer science teachers like to harp on their students to use lots of comments, but the problem in the microbit world is that the comments can end up taking up memory. And memory is sparse in the microbit, so We try to be careful about that. Document it somewhere else, like outside of the program in a separate document is preferable. I'm going to skip all the deeper nomenclature. And I think that's about it for now. Let's see here. We added the library already. Okay. This one's important. Okay, so I'll go ahead and chat you this link that I just followed. Should have been doing that all along, sorry. Let's see here. Chat, there we go. Paste. Okay, so this link let's try that again. Okay, so this is the API. So anytime you see from Cyberbot import star and you see something that doesn't make sense, especially if it starts with bot and parentheses, well, you'll see it in here. And so one that you're probably familiar with already is bot pin servo speed. See that? So if you saw that, you were just going through our tutorials, you could follow this link and look up servo speed and find out what that number you put in parentheses here is, like 75 or -75 versus what you put in here, which might have been 18 or 19 for the pin that you're using to control the servo. So this is our reference for that. Okay. Next up, we want to talk about navigation. Just a reminder, the microbit, when you write a program, when you say servo speed, like we just looked at, what the microbit actually does under the hood, this Cyberbot module, the import Cyberbot from Cyberbot import star, it actually communicates to this microcontroller, which is underneath the breadboard on your Cyberbot board. And then this microcontroller is the one that sends a continuous stream of signals to the servos to make them turn. It also has access to set voltages, to talk to these little numbered sockets on the breadboard, and a number of other things. We'll get to have some hands-on experience with that, so more about that later. All right, so back to servo speed. When you use 75, we turn counterclockwise at about 3/4 speed. 100 would be full speed, 50 would be half speed, 25 quarter speed, so on and so forth. You make that number negative, it makes the servo same type of control, but in the clockwise direction. Do we have any questions there? How are you guys all feeling about that one? Okay, just jump in and stop.
Andy, I'm feeling lost. What are we going over right now?
Well, okay, so on there was some, the homework assignment included going through some programming tutorials. And so
I thought we were only supposed to stop at building it.
Oh.
Yeah.
Well, that explains it.
That's why I saw a couple checks too, because you said we were supposed to do those ones on the page that said building it, and after you put the batteries in it and you connect everything, I have lights, but nothing moves. So I thought, well, were we supposed to do something else? But you said just to build it.
Okay. Well, I have to go back and look at the video, but I thought I said we're going to have you build it, and then I'm going to include some other links in the homework. And so I sent out a homework email.
I missed it. I don't know who else missed it, but I missed that.
Can we get some thumbs up on who missed it, who didn't do any programming tutorial or navigation? There's one.
I just built it.
Okay.
Yep. See?
All right. Well, let's approach this differently then.
Sorry.
We'll let that quick programming whirlwind tour be water under the bridge for now. I would suggest rewatching the YouTube video after you've tried it out, and we'll go a little slower here. So we want to make our wheels turn, and we're going to use Python. And one quick thing is, as you're looking at your robot, you want the breadboard mounted close to the wheels. So I'd like everybody to check and make sure that the white board that's on top is near the wheels. And if it is, forward is towards the whiteboard. Backwards, of course, is towards the tail wheel. That's what we call it. And then if you imagine that you're sitting on that whiteboard with your feet hanging off the front, that would be how you're driving it. So then you can think about how you'd make a left turn and a right turn. But the trickiest part is that you want the right wheel, if you want to go forward, the right wheel has to be turning clockwise. Well, if you turn the bot around and look at the left wheel, forward becomes counterclockwise. Does that make sense? To go forward, because the servos are facing opposite directions, they have to be turning opposite directions. It's a very important point. And so we'll need to make our robot go forward by all right, so let's have everybody open up their microbit editor and plug in their robot, and we'll test it out and make sure we can go forward together. So the first thing we want to do is hit load save and then make sure to bring in our and then browse file. And then in our downloads, we can grab cyberbot.py. And then then check load save again. And you want to make sure that you've got cyberbot.py and your main file. Once you've got cyberbot.py in there, we'll be ready to go.
All right, so we're hitting download and then going, or are we going to the backwards, those arrows? Got it.
Okay, so load save, yeah, the third button over. Click load save.
Yeah.
And then or browse for a file. Okay, and then we've got to hunt down that cyberbot.py file.
That we put in the other day?
Yes.
Okay.
The other thing you can do is just open up a hex file that
for Monday.
Yeah, you can also optionally just open up a hex file from Monday. But
Okay, so
cyberbot.py
the CyberBot MicroPython thing, is that what we're opening?
Yes.
Okay. Just making sure I'm getting the right one. Doesn't have the zipper, so I think I'm good.
That's exactly right. You don't want to go into the zip. You want to just use the
CyberBot Py. That's when I open it, then it's there. Got it.
Yep.
Okay.
All right.
Now.
Okay, so once you've got that in, you're ready to say from cyberbot import star. And that will give us access to the servos. And we can say bot of 18, that should be the left servo, dot servo underscore speed of, let's do 25. And then bot. Now at this point, since the next statement is almost identical, what we can do is right click and copy, and then right click and paste, then change the 18 in our copy of that to 19, and the 25 in our copy to -25. Sleep 1000, no, let's go for 2 seconds. Now we can also shade and copy our little forward statements. and then paste those down below the sleep and change those 20. So what'll happen from this point is that the servos are moving, and then they're going to move for 2 seconds, and then we want to make them stop. And I mentioned earlier that 0 should make them stop since we centered our servos last time, but none will make them stop even if they've fallen a little bit out of calibration. Okay, so once you get that going, we'll need to connect our Cyberbot.
I have a quick question.
Yes.
Bot 18 and bot 19, what is the 18 and 19 referencing? Because
Okay,
the pins go into like P16 and P17. Is that two totally different things?
That is, okay, so look to the right of P16 and 17, and you should see P18 and 19.
Is that what my servo should be plugged in? Did I put them in the wrong one?
Yes.
Okay, thank you.
Oh, certainly.
And
also,
then what do we want to call this program?
Question, what do we want to call this program? Let's
Under
say
your script
forward
name.
2 seconds would be a great name.
and
All right.
Andy, I'll just add that the N in none needs to be capitalized. It is case sensitive.
Oh, thank you, Chuck. Yes, I wish I'd said that.
No, it's fine.
Yeah.
Is there a reason that you put the sleep 2000 before you put the speed to none?
Yes, basically the amount of time that, okay, so these two statements right here, servo speed 25 and negative 25, the microbit sends it to the propeller, and the propeller isn't going to do anything different. It'll start telling the servos to go, go, go. It'll repeat it 50 times a second, making those servos move. And it'll do that indefinitely. And so the idea is if we want it to go forward for 2 seconds, what we have to do is say, okay, do nothing for 2 seconds. And then after those 2 seconds, if we don't want the servos to just keep going indefinitely, we tell them to stop by setting the speed to none with a capital N.
So if you didn't put the sleep statement in, then there really wouldn't be any time for them to execute line 4 and 5?
Not exactly. If our program just looked like this, the servos would just turn indefinitely at a quarter speed, counterclockwise and clockwise respectively.
But if you put in if you set them then to none right away and you didn't put in the sleep command.
Like so, like that?
Yeah.
Yeah, then you might see a twitch. I don't even know if you'll see a twitch. I heard a twitch.
So should our thing be set to 2 or 0 right now for our servos?
Set it to 2.
Okay. All right. And then are we running this or are we?
Yeah, so yes, definitely flash it. So you want to hit the make sure you're connected. Okay, so I'm
How are you supposed to know? Because you hit the download, right?
Well,
No.
all right now I am disconnected. See how the little chain link is open?
Right.
And it says connect. Well, also it says download over here. So in order to connect, to make life easy, click connect, and when you're connected, it'll offer you to disconnect. So the chain link will be all together, and you'll have an option to disconnect, and it'll say flash over here. So that's the way you'll know you're connected.
Well, mine says disconnect if I put my.
Oh, you're good.
No, only if I put my mouse over it. I don't see the words, but I got to put the mouse and it looks like a smiley face like yours.
Yeah, okay, then you are connected. It may be that your window's a little smaller than mine. What it does is you lose the words.
Yeah, yeah.
So
Well, I'm
it's
doing
probably
2
like
screens
that.
so I can do what you're doing and see that I'm doing it right on my screen. So.
Yes, exactly, which thank you. I'm really glad you're doing it that way. That's perfect.
Okay. So now if we hit download, it should move or not?
Well, hopefully it says flash. If you hit flash and you're set to position 2 on the switch on the bot.
Yeah.
So this should be to position 2 with 2
Yeah.
green lights on. So I'll go ahead and flash it.
No? Okay.
Oh no. All right. And so my robot,
Mine isn't moving. Mine did everything until it was time to move it.
oh really? Okay,
Yep.
so check your batteries. Do you have, this one
Just
only
put
has,
them in.
okay.
Oh, wait. Okay. One
Is-
popped out. Let's try it.
To 2?
Yes, we want to have the power switch set to 2.
Okay. Yep. I'm not getting it. It's not moving.
Okay, so can we have a breakout room
Set
for,
up right now.
all right.
Thank you.
Did you make sure that you put one of the bots at 18 and one at 19? Because I didn't do that at first, and so the thing just sat there.
On, what do you mean put it at 18 and 19?
Well, where it says bot 18, and then
Yeah, I
you
did that.
copy and paste.
Yep.
Make
I
sure
got
you
that.
change the other one to 19, because I didn't do that.
Yeah, I did that. Everything says it's nothing. I'm not getting an error in the program or anything. It just isn't moving.
Okay, so we'll have you go to a breakout room. How are we doing? Is I want to make sure that everybody's got their robot moving forward for 2 seconds. Getting some thumbs up. Oh, good. I'm seeing a lot of thumbs up.
This is where my helper will come and bother me.
Yeah, because it's of great interest.
Yeah, right now he's sleeping. Let him stay that way.
Okay. So I'm going to assume that everybody else who's not in a breakout room got their robot to move forward for 3 seconds. Please unmute yourself and say, "Hey, Andy," if you're not there. So how about if we try to make it go backwards for 2 seconds now? So I think I'm going to switch out robots here. Okay, so since I just switched robots, I have to hit connect again. All right, so hopefully I'm ready here. I had a battery pop out too. All right, so would anybody like to venture a guess as to how we would go backwards or how we would adjust our current statements for going backwards? Let's do this first. Okay, let's shade the 3 commands that I have shaded, Servo Speed 25 and negative 25 and Sleep 2000. And let's go ahead and copy that and then paste it in above the none statements so that we have it like this. Okay, so with this program, all we're going to do is go forward for 2 seconds and then forward for 2 more seconds before we shut down. Now I want to change these 2 statements to make it go backward. Does anybody want to venture a guess as to how to do that?
You have 2 guesses in the chat already. We have one that says
thank you. Oh,
swap
I
on.
see.
You got them?
Yeah, perfect. So from Brian Kelly, we have changed 25 negative 25 to negative 25 25. That is exactly right.
Brittany says it too, and Renee's working on it also. Yep.
Okay, you guys are really cruising. Perfect. All right, so let's try flashing that. All right, now some of you may have noticed at this slow speed, oh, by the way, if you want to restart that program, see where the USB cable comes into the back here? There's a reset button right next to it, right here. And you can press and release that reset button, set it back down, and it will back up and go forward again. And you may have noticed that it doesn't go perfectly straight. So look carefully at the straight forward that I have on my screen and then watch your bot. Looks like mine is curving a little to the right on forward and a little to the left on backwards. Anybody else see that?
Yeah.
Okay. Now that's a thing that's really part of the servos. If you have a chosen speed that you want the servos to go, and you're curving like that. In my case, I was curving to the right. Well, that means that on line 4 here, my left wheel was going too fast. So if I want to try to straighten it out, I'll reduce the value for the left speed and then retry the code. Okay, it's curving less. Now I'm only addressing the forward part right now. Tune the backwards later. Okay, now I'm flashing again after having reduced the left speed. Oh, look at that. So again, pay only attention to the forward. Now it's actually veering just slightly to the left. So I might have overdone it by reducing that to 17. I'll try maybe 19. So if you need to straighten out your robot's travel, oh, that's perfect. Okay, so for me, 19 on the left and 25 on the right was the way to, it's still curving a little bit, but you get the idea, hopefully, that you can reduce the speed of the faster wheel. Now, you might be wondering, well, why didn't he just speed up the slower wheel? Well, if you're going at top speed, that won't be an option. So that's why I always err on the side of slowing down the faster wheel. So we can do the same thing, and this is something that we go through in the tutorials. So that's how to straighten out your robot's path. There is an alternate way for those of you expert users out there. It's the Feedback 360 servo. I can add this link to the recap email or copy link address. I'll paste it in here. This Feedback 360 servo has a third wire on it. See, there's black, red, and white, just like your normal cable, but there's also a yellow wire on there too. That is a feedback wire. And what it does is it tells the microcontroller on the board, hey, what is my exact position right now? And the board actually has built into it the ability to take that exact position and make speed adjustments automatically for you. So you just, in your code, you call out the speed or the position, and it'll go straight to it. So that's kind of a neat thing for if you want to soup up your Cyberbot. Okay, folks, how are we doing so far? Questions? Good. All right, so now if we've got forward and backward here, what about turning? I'm going to copy and paste again. I'm just going to give you guys the answer to that. Here's a right turn. And here's a left turn. These are the in-place versions. So I'm going to take all this code and paste it into the chat window. You can actually, hopefully I did it right. Let me test it. It's not really a good idea to share code if it's, okay, forward, backward, right, left. Perfect. Okay, and I'll make that 25. Okay, so this is on its way to the chat. If you have your own code already, that also is fine. Wait a minute. Did everybody get my chat, or have?
You have to click everyone, Andy. I got your last one, but I didn't have this one.
Okay.
While you're doing that, real good question came up from CC Travers in the chat. It seems that my wheel needs speed adjustments to go straight forward, but not for going backward. That seems odd. And my explanation for this, Andy, correct me if I'm wrong, is that when you adjust your servos with a screwdriver, that's an analog adjustment. And now we're applying digital values to something where everyone has different, hypothetically, right, different analog settings. So going forwards, going backwards, you may have different digital adjustments to overcome that analog adjustment that's different on every servo. So going forwards, going backwards, even left wheel to right wheel are going to have different values because you adjusted them all with an analog control versus digital.
Yes, I think I'm remembering back to my physics class when they talk about sources of error. And I think that's definitely one of them. And I honestly don't know which is going to be more, but the other possibility or another source of error is simply that the motor may be more efficient turning one direction than the other. The gearbox may be more optimized for turning counterclockwise than clockwise or vice versa. Those are all possibilities in what throws it off. And so straightening your robot out isn't everyone publicly and privately. Let's see if I paste it in now.
Here we go.
Okay, did my code come through this time?
Not yet.
Yeah.
Everyone in the meeting, paste, bam.
There it is.
All right.
Oh, there it is. Okay.
Yeah, so you can copy and paste that into your browser.
Andy, you started to say regarding the physics of it, because I was worried that possibly for the students it might be a mechanical issue too, because with it being separate axles, that one could be up further on the chassis versus the other. Could that be an issue as well with it turning in one direction or the other?
Well, as far as the turns, yes, you can really change the geometry of the turns. I visited a junior high school once and had just a complete Picasso robot in my hand briefly. I loved it. Basically, by the way, my batteries are low. See that flashing red light? Keep an eye out for that. If your students are having trouble with their robot and you see the red light either flashing or solid, it means that the batteries need some attention. Okay, so this board was on backwards and one of the servos was on the outside and forward. The other servo was on the inside and backward. It was as lopsided as it could possibly be. It still responded to the programs just fine, but yeah, the geometry of the turns was changed somewhat because of that. And they had to make adjustments as they were going through their mazes and so on. Okay, so okay, so we're gonna go ahead and save this as forward, backward, left, right navigation. Okay, so hit load save and download project hex, and we'll have a copy of that. Now, what I want to show you is a way to do this. Let's say that we want to draw a square. Maybe we'll go forward for 2 seconds, and then maybe we want to turn left for 2 seconds. Okay, so I just changed my program by deleting everything but the forward. The pound sign is the way to add a notation to your program. Okay, so here we are. We're going forward and then left and then stopping. Now, I'd like everybody to test and tune to have it go forward and then get it to turn left by 90 degrees. And you can either speed up your servos if you want it to turn further, or you can change the amount of time. So the variable is your choice. So mine didn't quite make it all the way to the left. And I'm just gonna use 2 seconds as my maneuver times and just change everybody to 30 here. See how that works. Okay, on my turn, think I actually need to go to about 2800 to get a 90-degree turn. Maybe 3100. Okay, hopefully you guys are also experimenting. So there I am moving forward and turning in place. I still haven't quite made that full turn. Might be because I didn't have both of my, or I didn't get all my maneuvers to 30. Okay, I think that's a satisfactory forward and left. I'll show you my screen in a minute, even paste it in case you guys want to try it. So there I go forward. And again, we need to tune for straight ahead, but I've roughly got forward and left. And I just pasted my adjusted code in, and you guys can try it out. I'm also going to swap out my batteries. So I guess one thing to note is that if you forget to turn your robot off, it can drain the batteries. And so be good with your students about having them turn the switch off and actually unplug the barrel jack. So for example, now if I run it, it should be a little bit more peppy. Yeah, look at it moving right along. Okay, so now it's turning a little too far because I have brand new batteries in it. And that is something to warn your students about in terms of needing to recalibrate. Okay. Now, once we've got this, okay, now we've got some code to make it go forward, turn left. Well, if we wanted to draw a box, we could just copy and paste that 4 times, right?
Mm-hmm.
And then we'd have every side of a box. So we're all good with that? Is that cool? I can just skip that one?
Yeah.
Okay. Python and any programming language is exceedingly good at doing things repetitively. So instead of copying and pasting this block of statements 4 times, that's going to eat up memory for one thing. What we can do is use the built-in Python commands that will make it do it 4 times, and that's for n in range 0, 4. So it'll do it for 0, for 1, for 2, and for 3. And just to make it fancy, we'll say display dot show n. I feel like that's not right. Chuck, did I mess it up? We'll find out.
Sorry, I was handling chats.
Oh, sorry.
No, it's fine.
Display dot show of n. Should that show me the number?
I think you need a colon at the end of the 4 line.
Oh, thank you.
Josh, Matt, can you take a look at his code real quick?
I'm going to try it.
Yeah, do it.
Let's just see if it blows up. Oh, look at that. 0. Okay, it just did its first turn. Now we got 1. Heavens, my batteries are still low. 2 and 3 coming up. All right, so let's save this one as square.
And for those who are keeping track at home, right when Andy started the loop, everything indented and everything that stays indented is going to run in that loop. And as soon as you come out of the indent, you're out of the loop.
Yeah, so these statements will get repeated 4 times. First time n will be 0, second time n will be 1, third time n will be 2, fourth time n will be 3. When it reaches 4, it says, I'm not going to do it. I'm out of here. Inclusive of the first value and exclusive of the last value.
Okay,
it does
so are we supposed to change the 0 to 1 each time?
No, it does it for you. Basically, it takes n, and it sets n to 0 the first time through the loop. We don't actually need that if we're not showing it on the display. But I wanted to show it on the display so that you guys could have a better feel of knowing that an index is kept in a for loop, that it counts how many times. We take a variable, n, and we set it to 0 and do everything in here. Once we're done and we repeat, it sets it to 1, then goes back through and does everything. Now, the only difference is that display.show is going to show us a 1 instead of a 0. But there are so many programming applications where we need to count through a bunch of things as we're going. We need to know that the 5th character was entered and maybe do something about it when it was. So let me paste this one to you.
So, and you need the bottom part that says none and none, right? For your, but you need the lines 13 and 14 for stop when it's done, correct?
Now notice that the answer is yes, but notice also that this is not indented.
Right, I saw that.
Yeah, so only what's immediately below and indented from the 4 and in range 04 will get repeated. And then once it's done with those 4 repetitions, then it'll move on and run into those 2.
Gotcha.
And Laura, you might have been in the breakout room, but what we're using none for is you can use 0, but if your servos aren't centered, they still might twitch or rotate. So none actually shuts off power to the servo. So it makes your bot truly stop at the end of that.
Gotcha. And you don't want that 13 and 14 to be indented at all, correct?
It would have no difference if you indented it. It's more efficient if you leave it outside of the loop.
Leave it outside. Okay. I was in the, we figured out what the problem was. I'm having lots of lovely fail moves here. So
you and me both.
Yes, I didn't have my servos plugged into 3 prongs. I had them plugged into 2. So I go, well, where'd that 4th one come from?
You know, I honestly had a feeling that was the case, but
well, you should have said something because it was like, oh, man.
Well, I didn't want to. We could have ended up burning up, 10 minutes pretty quickly. So
it's okay. We figured it out.
Yeah, if my hunch wasn't right, it would have taken time. All right, so this is an example of a loop, and this is a nice way of learning essential programming concepts in Python. Is to and when we do it, have you guys did you guys get the chat? Did you try pasting it in? Did we get kind of a kind of sort of square that needs some tuning? I did paste this in the chat. Is it Lori that was out in the?
Yeah. Yep. I got it. I got all 3 programs saved. The first one we did, the turn and left, and this one. So
okay. So try running this and let's see if you get a kind of sort of square that needs some tuning.
Okay.
I'll go ahead and maybe show mine over here. You can, by the way, you can unplug your robot. You'll have to re-hit the connect button when you plug it back in. But so you can unplug your robot as mine is there, and then hit that reset button. Well, you got to turn power on, and then and hit the reset button. And nothing's happening. Why is nothing happening? Probably because my batteries were out. Okay, so here I go. First 90-degree turn. Second 90-degree turn. Ish. And back to the start. So again, needs lots of tuning, but that's a good way to make a square. And now notice I unplugged it from the USB, so my I get this disconnected message. So so we'll go ahead and plug it back in. And at this point, when we switch back to, you'll need to close the error and just go ahead and hit reconnect. And then you'll be ready to load the next program. Okay, so quick recap then on navigation. This is slide 81, and it shows you the recipes. Now, in this case, slide 81 is saying if you want to turn right, see how they're using 0 for the right wheel? That's really okay. It might go slowly even if it's out of center, but that'll mostly stop the right wheel, and then the left wheel is going at 3/4 speed. So so that is another way. Instead of turning in place like the code example you just tried out, you can pivot by just keeping one wheel still and letting the other run. And then here is turning in place. These are higher speed maneuvers.
And if I could just interrupt real quick, I know we're at the bottom of the hour, and before we lose anybody, I just wanted to say, there was a comment in the chat earlier to me that when you were viewing the learn.parallax.com site, your instance of it was HTTPS. And on us minions, we can only get the HTTP version, and it was coming up flagged as non-secure. I've emailed with Ken, and we're actually, that's going to be addressed. So for those of you who have IT departments that hesitate to allow you to visit HTTP sites, learn.parallax.com will be HTTPS enabled shortly for the rest of us.
Thank you very much, Chuck. That is excellent.
And this is saved. And then Andy, this is in our presentation stuff that we saved on Monday, right? It's just continuing to be added to?
Yes.
For Google Docs? Okay.
Yeah, okay. This Google presentation, you know, I certainly recommend downloading a local copy because we may make changes to it. Like I was actually planning on splitting this into 3 sessions worth of presentations. So make a copy, but we'll always have the links on learn.parallax.com.
Okay.
And basically you'll go to the educators.
Okay, gotcha.
And Cyberbot resources, and then here's the link to the slide material.
Gotcha. Okay. Well, I have another meeting, so that's why I was asking, and I'll see you guys on Friday.
Okay, please keep an eye open for homework.
Okay.
And everybody make sure to do it this time. We're gonna build some circuits. We're gonna build a circuit and then test it on Friday and make it do something. Okay.
All right. I'll watch for your email and homework.
Okay.
Bye,
yes.
guys.
And you've got some to catch. You may have some if you didn't do the chapters that we talked about. You might have some to catch up on as well.
Okay. Thank you.
All right. So yes, we are at the end of the session. I'm happy to keep going, but I know that many of you may have other things scheduled. So we can also just do tech support and just do some extra Q&As for folks who maybe want extra stuff to accelerate their learning path. I'm open to all that. Just go ahead and unmute yourself and shout it out. Otherwise, please, everybody, keep an eye open for the homework email. I'm going to refer you to an earlier email because if you didn't do that homework, you'll end up feeling lost. And then there will be some current homework due Friday as well. All right.
Okay.
So,
question if we're taking those at this point.
Let's go.
Go ahead, Joseph.
As you were kind of cruising through the code examples, I missed on the random thing. Is that a separate library that you need to get?
It is a separate module. Yes, I'm on my way back to that.
And I couldn't find it in the CyberBot download, so I maybe need to go back and download a completely different